Today we will discuss about isomerism in coordination compounds. So what do you mean by isomerism? Compounds which are having same molecular formula but different structural formula or spatial arrangement of atoms are called isomers, and the phenomenon is called isomerism. So isomerism is of two types, generally structural isomerism and stereoisomerism. The isomerism is generated because of the difference in their structural formula or the spatial arrangement of atoms. We have to deal with each isomerism and its classification. First one is structural isomerism, that is classified into four. One is ionization isomerism, second one is linkage isomerism, third is coordination isomerism, fourth is solvate isomerism. Now, structural isomerism, as I told you, it is an isomer which differ in their structural arrangement of ligands around the central atom. The structural isomerism can further be classified into four. First one is ionization isomerism. What do you mean by ionization isomerism? Ionization isomerism arises due to the interchange of ions between the inside and outside of coordination sphere. As you can see in this example of cobalt, you have cobalt and ammonia and then sulfate in a square bracket, then bromine is outside the coordination sphere, and other one is again a cobalt complex with ammonia, but bromine came inside and sulfate went outside. So it is this kind of isomerism where you have the interchange between the ions takes place between inside and outside of a coordination sphere. So there can be many examples of ionization isomerism where you will find the interchange of ions from outside and inside of the coordination sphere. Next one is linkage isomerism. What is linkage isomerism? It arises in a coordination compound containing ambidentate ligand, which can bind to the central atom through one or more donor atoms. See the example. It is again a cobalt complex. You have ammonia. In both the examples you have ammonia. Chlorine is also there. But in the case of NO2, NO2 is present as NO2 in one case and the other one as ONO. That is, the NO2 is an ambidentate ligand. Ambidentate ligand means it can coordinate in two different fashion, or either ONO or like NO2. So like that, if we have two complexes in that way where you have presence of this ambidentate ligand is there, they can show linkage isomerism. The linkage part is different. Next is coordination isomerism. If both anionic and cationic parts are complexes, the isomerism arising due to the interchange of ligands between the cationic and anionic entities is coordination isomerism. Coordination isomerism will be seen when you have a cationic and anionic part should be there in a complex, and the interchange between these two parts is coordination isomerism. The example given is this: cobalt, ammonia and chromium with the cyanide. So as you can see, the ammonia and cyanide are interchanging in the example. So there is an interchange that is happening between the cationic and anionic entities, that is coordination isomerism. Next is solvate isomerism. What is solvate isomerism and how it is generated? It is generated when the difference in the number of solvent molecule occur. The example, chromium with a 6 water molecule and chlorine present outside the coordination sphere is one thing. The other one is chromium with a 5 water molecule with the chlorine being the chlorine coming inside and chlorine and water present also outside. So there is a difference in the number of solvent molecules present inside and the outside of the coordination sphere. So that is where solvate isomerism takes place. So these four are the different types of structural isomerism. Now moving on. Now the second part is stereoisomerism. What is stereoisomerism? These are isomers which differ only in their spatial arrangement of ligand around the central atom. The arrangement of ligands around the central atom, the spatial arrangement, that is stereoisomerism. So this is of two types, geometrical isomerism and optical isomerism. These are the two different classification of stereoisomerism. You have to now study about each isomerism, geometrical isomerism and optical isomerism. First, geometrical isomerism. What do you mean by a geometrical isomerism? Geometrical isomerism is a type of isomerism that arises due to the difference in the arrangement of ligands around the central atom. So it is mainly found in coordination complexes with the coordination number either 4 or 6. So 4 means it is a square planar complex, 6 means it is an octahedral complex. So geometrical isomerism is the difference in the arrangement of the ligands around the central atom. So from the example of platinum complex, you can see that ammonia is present on the same side, and that is called a cis isomer. And if the ammonia is on the opposite side, that is called a trans isomer. That is a two classification in geometrical isomerism, where the same ligands on the same side are cis isomer and the same ligands on the opposite side are called a trans isomer. This is an example. Platinum, ammonia, twice Cl2 is a complex which can exist in two different ways, either in its cis form or in trans form. So as I told, that is a square planar complex. Now it is octahedral complex. Octahedral complex with the formula MX2L4 can also show cis and trans isomer. As you can see, this is an example of a cobalt complex where you can see ammonia is all in the same side of the atom, central atom, that is cis isomer. But in the case of trans isomer, the ammonia is present as opposite, or you can say that the chlorine is opposite. So in that way, it is acting as a trans isomer. So geometrical isomerism is generally classified into two, that is cis isomer and trans isomer. Now, optical isomerism. Where can you find optical isomerism? This type of isomerism arises when bidentate ligands are present in the complex. Bidentate ligands, in the earlier classes I told, it can link to the central atom with the help of two or more different types of its atoms. The presence of in the case of ethylene diamine, that is EN. EN is an example of a bidentate ligand which can exist in two different ways. It can coordinate to the central atom in two different ways. So this is an example. Ethylene diamine can coordinate in two different ways to the metal atom, and that can also exist in two different fashion. So this optical isomerism can be generally classified as FAC and MER isomerism. So FAC isomerism is where the similar ligands occupying the three adjacent position of an octahedral phase, that is FAC or facial isomer. But MER isomer is when the positions are around the meridian of the octahedron. So that is meridional or MER isomer. This is an example of a cobalt complex. You can see that all the NO2 molecules are coming together. All the ligands, NO2 ligands are together on the three adjacent sides. So it is FAC. And in the case of MER isomer, that is in the different side. So that is meridional or MER isomer. Optical isomers, isomerism is a very important term because optical isomers are mirror images that cannot be superimposed on one another. And there is a very specific term that you have to learn here, that is called enantiomers. So enantiomers are basically optical isomers which are mirror images that cannot be superimposed to each other. You can the two forms of this optical isomers are dextro and levo, D and L. For example, in the case of PtCl2En twice plus, it is a complex, platinum complex. Here you can say that only the cis isomer show optical activity. The trans isomer of this complex, particular complex, cannot show optical activity because it has a plane of symmetry and it is optically inactive. So if there is a plane of symmetry in any of the complexes, that particular complex cannot show optical activity. So this is an example of that platinum complex. As I told you, this is a dextroform and the mirror image of it, this is levoform. There are different types of applications of coordination complexes. Coordination complexes can be used in qualitative and quantitative analysis for the detection of some ions in our laboratories, and in water treatment. Other application is in metallurgy, and then in biological applications. As you know that many of the complexes that we see in day-to-day life is a complex, it's a coordination compound. For example, chlorophyll is a coordination compound of magnesium. Hemoglobin is a coordination compound of iron. So that and vitamin B12 is a coordination compound of cobalt. Other applications is in catalysis, electroplating, photography, and in medicine. Specifically cisplatin is a coordination compound which is used for the treatment of cancer. Then EDTA is another example which is used for the lead poisoning. So these are the basic things of isomerism and the applications in coordination compounds.